sleepy time-space drifts a little lower now, to the thin, thick, and utterly foreign blankets that wrap other worlds. Imagine listening to an atmosphere as if it were a slow, breathing thing. Inhale, exhale, the rise and fall of pressure and temperature like long, measured tides. On Earth, clouds are made of the water, and we know their language well. Cumulus puffs, wisps of cirrus, slow fog that settles into valleys, but step beyond the familiar and the vocabulary changes. Clouds can be metal, rock, sulfur, or glass, and their rains can glitter, hiss, or strike like droplets of molten stone. Begin with tidally locked planets, those that show one face forever to their star and another forever to space. Their skies memorize a permanent day and a permanent night, and the boundary between them, the terminator, becomes a place of endless dusk. Imagine wind rushing from the furnace of the day side to the frozen dark, carrying heat as if pulling a blanket across a bed. That wind sculpts clouds into long bands, stitching weather patterns that slowly march around the limb. The terminator is where condensates may form, vapors lifted by day, cooled and condensed as they cross the dusk, then perhaps swept back again. Picture that loop over and over, a slow, endless folding of vapor and chill. Now picture a world where temperatures are so fierce that rocks evaporate high in the atmosphere. Silicate vapor, the same stuff that makes granite and sand, floats like a ghost. As it cools, it condenses into droplets that might fall as glass rain. Each impact is a tiny bright chime on the planet's surface, and collectively, they form a steady, distant shimmer. Elsewhere, metal vapors can condense into reflective clouds of iron or magnesium, scattering light in soft, metallic glows that shift with the angle of the star. Let that image wash over you slowly. Tiny metallic beads drifting, catching, and returning light like a cradle, rocking in space. Some atmospheres are thick with sulfuric or hydrochloric acids. Their clouds smell alien if you could smell them. Heavy and slow, lightning there might crack with different colors because of unfamiliar chemistry, painting the sky in hues your mind can imagine, but not quite name. In other places, methane and ethane form oceans and clouds in a cryogenic cycle, vaporize, condense, drizzle, evaporate again, a refrigeration-like weather system that creeps across the surface at glacial tempos. The motions are lethargic by Earth standards, but rich in texture and repetition. Clouds are not only painters of the sky, they are agents of climate. They trap heat, reflect starlight, seed storms, and hide deeper atmospheric layers. Thick cloud decks can make a planet look featureless, soft as a pillow, while patchy clouds let glimpses of roiling colors leak through. Tiny aerosols and photochemical smogs born from intense stellar radiation paint the upper atmosphere with long-lived hazes that slowly descend, adding an extra layer of repetition to the planet's slow song. Imagine observing all this from afar, spectra showing muted absorption bands, because clouds hide the chemistry beneath, or peculiar broad features that point to crystals and metal droplets. Each observation is another gentle stroke in the picture, another refrain in an ongoing lullaby of vapor and dust. As sleepy time space guides you through these skies, let the cadence settle. Vapor rises, cools, condenses, falls, winds push, clouds shift, and the strange weather continues, steady and patient. Like a slow, sleepy time space slips a little deeper now, beneath the visible veils, and into the slow, patient mechanics that shape worlds from the inside out. Imagine a planet not as a static globe, but as a layered instrument, a brittle crust, a denser mantle that flows like very thick syrup over geologic time, and a core where heat is born and slowly released. That internal warmth, left over from formation, augmented by radioactive decay, and sometimes driven by gravitational squeezing, becomes the heartbeat of volcanism, plate motions, and the secret circulation of subsurface oceans. Tidal heating is a particular, gentle torment that some moons and planets endure. When a world is pulled and stretched by a nearby giant, like a moon dancing close to its planet, its interior flexes. That flexing generates heat. Imagine a piece of warm wax being kneaded slowly. Friction turns movement into warmth, and that warmth can keep ice soft, keep oceans liquid beneath thick shells, or feed continual volcanoes at the surface. In our imaginings, tidal heating is a slow, repetitive massage, a rhythmic maintenance of interior motion that never rushes. Volcanism itself comes in varieties. There are basaltic flows that spread quietly across plains and explosive eruptions that fling ash into the thin air of small worlds on icy bodies. The parallel is cryovolcanism. Instead of molten rock, cold mixtures of water, ammonia, or methane are expelled, freezing into frost, and then slowly sublimating away. Picture geysers in near silence, jets that arc into space and leave a faint, repeating chorus of falling particles. Those particles form tenuous rings or feed a planet's tenuous atmosphere, adding to an ongoing cycle of deposition and drift. Plate tectonics, where present, is a slow conveyor belt. The planetary skin creeping, colliding, and recycling itself. The grinding of plates creates mountain ranges, opens ocean basins, and can power long-lived volcanic provinces. On some exoplanets, plate tectonics might be more sluggish or more frenetic than on Earth, depending on composition and internal heat. Envision mountain building not as violence, but as a protracted push, a slow compression that folds crustal sheets like pages, turning in a very long book. Magnetic fields are the invisible blankets that protect and shape atmospheres. Generated by convecting, conductive fluids in a spinning core, a magnetic field deflects charged particles from the parent star and can produce auroras, soft, drifting curtains of light at high latitudes. Imagine standing at the edge of one, curtains shimmering, slow curtains that sway with the wind of charged particles, painting the polar sky in a patient, colorless ballet. Where magnetic fields are absent or weak, stellar wind strips away atmospheric layers over eons, Where they are strong, atmospheres can persist and quietly evolve. Subsurface oceans, tucked beneath kilometers of ice, are places of hush and slow circulation. Convection within these oceans can transport chemical energy and maintain gentle thermal gradients. Imagine currents moving under a frozen lid, transporting warm, mineral-rich water from warmer regions to cooler ones. Each turn of the current, a low-frequency motion. Those hidden seas can be chemically active, driven by hydrothermal vents that exhale mineral-laden fluids, tiny, persistent plumes that in their repetition form a steady underwater weather. Rings and moons add texture to planetary lives. Rings whisper of collisions and gradual decay. Moons tug gently, holding rhythms in orbital resonances that keep systems in slow, repeating patterns. Every tug is a tiny nudge in a prolonged dance, and every ring particle orbits like a bead on a string. As sleepy time-space guides these images, tidal warming, cryovolcanic plumes, magnetic lullabies, and secret seas, let each mechanism be a repeating motion. Flex, warm, release, rise, condense, fall, swirl, protect, shimmer,